Welcome to the final presentation of Engineering Exploration course. We are glad to present our first project of Engineering Exploration course. To begin with the presentation, the title of our project is Infinite Mirror Clock. The need statement of this project is Decoratives. The team members are Priyanka, Nagashri, Ganesh and Shashank. To complete this project, we had to follow the 5 basic steps of engineering design process, that is problem definition, conceptual design, product architecture, detailed designing and design communication. The first step is problem definition. The model is a decorative product which is portable and durable for a long time. The model should be able to demonstrate the function like display time as well as temperature, produce sound and display rainbow effect. The estimated cost of this product is ₹2,000. At the end, it is going to be a fascinating one. Problem definition includes objective, constraints and functions. Here are the objective, constraints and functions. The next part we did was to develop the function tree. The functions are listed here. That is, first one is to draw attention. Second, to generate light patterns. Third, to display time. And fourth, to display temperature. Here we can see that the functions are further divided into subfunctions like. In the first one, it is further divided into playing music and convertible mirror. Second one into rainbow effects, and lastly the last function includes the subfunctions, that is to vary the brightness of the LCD screen. We can see that in figure 2 all the subfunctions are clustered with their respective functions as shown.
The subsystems identified are as follows: light unit, sensing unit, which includes temperature sensor and IR sensor, and sound unit. Second step is conceptual design. Based on the functions, different concepts were developed. We developed 4 different concepts, in which the first one was infinity mirror clock. The second concept was the splash clock. Concept 3 was the word clock. Concept 4, the digital clock. Among the generated concepts, we have to choose the best alternative based on the pug chart. We created a pug chart and chosen concept 1 as the best alternative. Figure 1 shows the basic model of our project where the LED lights are placed on the circumference of the mirror. Figure 2 consists of 3 diagrams which separates the front, middle and back view of the clock. Figure 3 is the final outlook of our model. We will be placing a peacock on the top of our model, therefore making it an attractive one.
Now let us begin with the third step of the engineering design process, that is product architecture. Based on the functions and sub-functions, interaction among them were analyzed. Interactions are identified in terms of the material, data and spatial. Understanding the interactions, we had to visualize our product, so we used Autodesk Inventor 2019 to develop the product architecture of our model. Here are the images and video of our design which we had to develop in Autodesk Inventor. Now let us watch the video. The next part was to design a circuit for our model. We designed a circuit in a Circuito app, and here is a snapshot of the circuit. Third step of the engineering design process is detailed designing. To understand the working mechanism of our model, we designed a flowchart. As you can see, when we switch on the system, it starts displaying rainbow effect as well as the temperature. According to our first condition, when some obstruction is detected, it switches off all the light until the obstruction is removed. Next, when the switch button is on, it starts displaying the time. If toggle is pressed, the sound is produced. Besides the flowchart, there is a circuit diagram of the entire system which can perform all the functions mentioned before. The table here indicates all the materials required for our project. It can also be used to calculate the cost of our project.
Motor sizing and battery sizing of the entire system. Motor sizing and battery sizing is also a very important task to be done. We aren't using any motors in our project, so motor sizing is not required. In our project, we need 60 LEDs and we are using addressable pixel strip of 30 LEDs per meter. When calculations are done, we can notice that power consumed is 18 watt and voltage to be supplied is 5 volt. The model should run for 3 hours with an efficiency of 85%. When watt hour and ampere hour are calculated, the result are as follows: 63.52 watt hour and 12.7 ampere hour. So the proper battery to be used is 13 volt to 14 volt. Functional specifications of the entire system. To begin with the first function, convertible mirror, there is an IR sensor fixed at the bottom of the clock. When an obstacle is detected within the range of 5 to 10 cm, all the lights get off for some particular period of time. The second function is to produce sound. That is, it produces a buzzing sound when the toggle button is pressed. Third function is to display time, in which various indications of hour, minute, and second is given by the different colors of light. Fourth function is to display temperature. It displays the temperature within the range of -55 to -150 degrees Celsius, and here a potentiometer is also used to vary the brightness of the LCD screen. The last function is to display light pattern. The light patterns are displayed using a switch button. To understand the proper working of the model, let us move to the next part. We used a software called Tinkercad to develop our circuit. Here is the modeling and simulation of our project. The video demonstrates all the functions of our system. Let us watch the video. As soon as the simulation starts, there is a rainbow effect produced. Here is an IR sensor, and when input is given, all the lights get off for some time period and the system can be used as mirror. This demonstrates our first function of the system, that is convertible mirror. Moving on to the next function, there is a switch button, and when it is in on state, all the lights get off and get converted to clock. That is, it starts displaying the time. The separate blue color LED placed over there represent the hour hand of the clock, the red light represents the minute hand of the clock, and the light blue light represents the second hand of the clock. The third functionality of our clock is to display the temperature using potentiometer. The fourth functionality is to produce the sound using toggle button. When the toggle button is pressed, there is a buzzing sound produced. Here we can see that the light blue lights keep moving. One circle completion of this blue light indicates the completion of 60 seconds, that is 1 minute. After every minute, the red light shifts its position to the very next place. Similarly, one circle completion of red light indicates the completion of 60 minutes, that is 1 hour. The separate LED light placed on the outer surface of the mirror shifts to the very next place. This is how the circuit is designed and works, and this cycle continues. This shows the effect of light produced due to the mirror. This is how attractive it's going to look. Last step is design documentation. Here we updated all the documents related to this project on an application called GitHub. It has been a pleasure to be a part of this wonderful course subject, and we hope that we'll be getting such kind of opportunities in the upcoming semesters. It was a delightful as well as a learning experience to work on this project with a guide, Kaushik sir. It wouldn't have been a successful one without his guidance. Thank you so much, sir, for supporting and guiding us. We would also like to thank all other faculty members for supporting us. Thank you.